This set of notes will complete pages 47 and 48. On 47, we will complete circle theorem number 5 and number 7. And on page 48, we will look at circle theorem number 6 and number 8. So go ahead and turn to page 47 in your notes. I want you to give this page a title, and then the explore that we did in class, I would like you to tape those notes onto this page. And the way you can do that so you can still see underneath, so we're going to do some examples underneath, is to put 2 small pieces of tape along the left-hand side of your notes sheet. And that way you'll still be able to open it up and see all of the notes and the examples. So I'm going to complete my notes and then tape it in so it's not in my way as we're doing the examples. The first thing that I want you to think about is making sure that you have some kind of a summary for circle theorem number 5. And the way I chose to write that was arc, that will arc above AB, means arc AB plus arc DE will equal 2 times the angle at the intersection. So I'm going to highlight those so that I can see that in my notes. So arc AB is that arc plus arc DE. Oh, shoot. DE equals, and I'm not going to highlight that with the blue because the blue doesn't work very well, 2 times the intersection, so that angle at the intersection. Okay, let's look down at theorem number 6. So when we have an intersection that is outside of the circle, so on our first example our intersection was inside the circle. On this example, theorem 6, we have an intersection that's outside of the circle. So when that happens, we are going to take the outside arc and then subtract the inside arc. And that will equal 2 times the intersection of the secant lines. So 2 times that angle at F. All right, let's look over on the back. Make sure that you have filled in that when we have a tangent line, so I'm going to highlight the tangent line in green, and a radius of the circle, so let's highlight that radius. I'm going to do mine pink. That they always make a 90-degree angle. Okay, so this angle will always be 90 degrees. Okay. And then we also discovered that if we connect the intersection to the center of the circle, we end up with 2 pairs of congruent angles. So the 2 halves of the angle at the intersection are congruent, and the 2 halves of the angle at the center of the circle are congruent. In circle theorem number 8, we discovered the same thing we had discovered with circle theorem number 6, that when we have this intersection of tangent lines outside of the circle, we can take the outside arc and subtract the inside arc, and that will equal 2 times the intersection. I know that some of you, when you had discovered this relationship, wrote the relationship as the difference divided by 2 was going to equal the intersection. And that's perfectly fine. It's also true. I prefer to write it like this. I think it's easier for me to write equations when it's set up like this. But if you prefer to write it as dividing the difference by 2, you can certainly set up your equation in that way. All right, we'll refer back to those, but I would like to do some examples. So the examples on page 47, we're going to start with when we have the intersection inside the circle. So in example number 1, I just traced one of my circles from one of our homeworks, actually. So we have one of our arcs is 50 degrees and the other arc is 200. And our notes tell us that when the intersection is inside, we're going to add the 2 exterior arcs, and that will equal 2 times our intersection. So we're going to add 50 plus the 202, and that will equal 2 times the intersection. Anytime I have a question mark in my notes, I like to use an X. You could just as easily write that question mark. It doesn't really matter. So 50 plus 202 is 252 equals 2x. Divide both sides by 2, and we find that x equals 126 degrees. Okay. So for clarity's sake, let's just make sure we see that we added the outside arc together, and that was twice of our inside angle. All right, in example 2, this time instead of looking for the intersecting angle, we are looking for one of the arcs on the outside. I'm still going to write an equation just like we did the last time. So I'm going to add the 2 outside arcs, 179 plus, we don't know what the x is, so I'm just going to say plus x equals 2 times the angle at the center, so 2 times 121. Okay, so 179 plus x equals 2 times 121 is 242. Subtract 179 from both sides. And we find that x equals 63 degrees. Okay. All right. The next examples I want to do on this page are actually using circle theorem number 7, and we'll put all of the examples for circle theorems 6 and 8 on page 48. Since they are very similar, we'll put them all together. So remember that circle theorem number 7 was talking about tangent lines and the radius, and this situation, how we can use those relationships to solve problems. So in example number 1, we're told that this angle here is 34 degrees. Since I know that this line is a radius, and this line I highlighted in pink is a tangent line, we know that this entire angle is 90 degrees. So if I want to find this angle up here, I'm going to have to start by finding the other half of this 90 degree angle. So I can subtract 90 minus 34 and get 56. So we've found that this angle is 56 degrees. Since this side of this little triangle is also a radius, we know that those two sides are congruent, which means that these two base angles are also congruent. So the angle that we're looking for has to also equal 56 degrees. Let's see what I got. All right. So example number 2, we are looking for this half of the angle at the center of the circle. We know that we have this line is a radius and this line is a tangent line. So that tells us that this angle has to be a 90-degree angle. And if I highlight that line down the center connecting the circle and the center and the intersection, we see that we have a triangle here, and we can find this angle at the center by using our triangle angle sum theorem. So we have 180 degrees for all 3 angles. We're going to subtract the 90-degree angle and that 35-degree angle, and we end up with 55 degrees. And since we know from circle theorem number 7 that this angle and this angle are congruent, we know that the angle we are looking for is also 55 degrees. All right, let's move on to page 48. And we will complete some example problems for circle theorems 6 and 8. I would highlight on this page that our intersection is outside the circle. And I might even go back over onto page 47 and do the same thing, highlight that the intersection is inside the circle. That way, if you need to come back and reference these notes, you can quickly see which set you need to use. Okay. So, example 1, we have an intersection of those 2 secant lines outside the circle. And our notes tell us that if the intersection is outside, we need to take the outer arc, subtract the inner arc, and that will equal 2 times our intersection. So in this example, the outer arc is 121, and the inner arc is 61. And that should equal 2 times this intersection angle that we are looking for. So I'm going to write that as 2 times x. So to solve this, we can go ahead and subtract 121 minus 61, and that will give us 60 degrees equals 2x. Divide both sides by 2, and x equals 30. All right, let's go on to the next example. So in this example, we have tangent lines, and our intersection is outside the circle. We're looking for this angle again. This time they've told us the inside arc is 126. And notice on our notes that the outside outside arc and the inside arc make up the full circle, so full 360 degrees. So if I know that this arc is 126, to find the other arc, I can take 360 minus that 126. And we will get 234 degrees. So that tells us this outside arc is 234 degrees. So then we can go ahead and take the outside arc, 234, minus the inside arc, 126, and that equals 2 times our angle, which is what we're looking for, so that's our x. So 234 minus 126 gives us 108. We divide both sides by 2, and we find that x equals 54 degrees. In fact, we should come over here and remember to put our degrees over there too. All right. Moving on to example number 3, we still have an intersection outside of the circle, but this time instead of looking for that angle, we're looking for the inside arc. Notice that we have one secant line and one tangent line. It does not matter any combination of secant lines and tangent lines. As long as the intersection is outside the circle, we will subtract the two arcs, and that will equal twice the intersection. So our outside arc here is 140 degrees. Minus this time, we don't know that arc at the center, on the inside. So we are subtracting x, and that will equal 2 times 48. So we have 140 minus x equals 96. We have to subtract 140 from both sides. So don't forget to bring down this negative sign with the x. So 96 minus 140 gives us negative 44. So we can read this as the opposite of x equals negative 44. So I could just find that x equals 44. If the opposite is negative, then x has to equal 44 degrees. All right, let's look at example number 4. This time we have two tangent lines, and we are looking for that inside arc. And remember that in example number 2, when we were looking for this outside arc, we took 360 minus the inside arc. So we're going to do that again on example 4. And this outside arc is going to equal 360 minus x, because this inside arc is going to be the x that we are looking for in our problem. All right, so we're going to take the outside arc, which we found was 360 minus x. We're going to subtract the inside arc, which is the x that we're looking for, and that will equal 2 times our angle, so 2 times 50. So let's simplify this here. 360, we are subtracting one x and subtracting another x, so total we are subtracting 2 x's, and that's going to equal 100. We're going to subtract 360 from both sides. So negative 2x equals negative 260. Divide both sides by negative 2, and we find that x equals 130 degrees. And that's it for these notes.